like a boundary. They give the example of like a map. Between the United States and Canada, we have a boundary. And so that boundary represents everything above the boundary is Canada, everything below the boundary until our, southern border is the United States. Those are boundaries. And so they are actually a boundary line. And so when you graph inequalities, you are actually graphing the boundary line, and then you're shading which side of the line you're talking about. So if I said, I want you to shade the Canada part, well, you would draw the boundary line like they have done here, and you would draw this to represent the line itself, and then you would shade in the Canada part, because you would be telling me which part is Canada. Canada is not just the line. Canada is everything above the line, right? And so when you're graphing inequalities, that's what you're thinking of. You're going to first figure out what the boundary is. Does it include the boundary? And then which half of the boundary you're including. It kind of splits that plane in half. So let's do the first one here. It says graph x minus y is greater than or equal to -2. Now first, and they do this on the other ones, I always recommend that you graph these in slope-intercept form. You don't have to, but when you go to do your shading, it's a little more confusing in standard form. So I'm going to show you standard form, and then we're going to do one in slope-intercept form, okay? For standard form, the easiest thing to do is to get your intercepts, all right? It's the easiest thing to do. So remember, my x-intercept is when I put this number, that -2, over the number in front of my x, right, which is a 1. So my x-intercept is going to be at -2, and then I am going to plot that point. X-intercept at -2, all right? My y-intercept, all right? Well, that's what happens when I put this number over here, my c, over the number in front of my y, which is -1. So my y-intercept is +2. +2. Anytime you have 2 points, you have a line, right? And so what I need to do to graph this line is I need to just connect those points. But when I am talking about a boundary line, I need to decide if it includes the line. You are going to use the same logic as you did for those endpoints. Did it include the endpoints? How did we know? Well, we came back and we looked at this. If it was an or equal to, it included it. If it was not an or equal to, it did not. So does this one include my boundary line? It does. It is an or equal to. And so for this one, I am going to do a solid line. A solid line represents the fact that this includes my boundary. All right? It includes my boundary. Now I have to decide, do I shade above it or below it? Now, if you just look at this, you would tend to think that you would shave above it. Why would you think that? Because it's greater than. But when it's in standard form, you have to consider one more thing. What is in front of my y? There is a negative in front of my y. So I'm actually going to do the opposite. Because when you put it in standard form, you would divide by a negative. When you put it in slope-intercept, you would have divided by a negative. What happens to this guy when I divide by a negative? It flips. So when it's in standard form, you have to then go back to your y and say, is the number in front of my y positive? If it is, then I'm going to do whatever this guy says. Greater than would be above it, less than would be below it. But if the number in front of my y is negative, I'm going to do the opposite because it would flip it, okay? So this one, you would actually shade everything below it, all right? You can check this. Pick a point in your shaded area, plug it in, and see if you get a true statement, all right? So let's say I pick this point right here. I'm going to pick 0, 0 because that's an easy point to plug in. Is 0, 0 part of my shaded area? Yes, yes it is. So I'm going to say 0 minus 0 is greater than or equal to -2. Is 0 bigger than -2? Yes, it is. I shaded correctly, okay? I shaded correctly. So that is doing this in standard form. In standard form, you can just, you pick your intercepts, graph those, and then shade accordingly. But you have to be careful that you pay attention to what's in front of your y. All right, let's look at example 2, graphing in slope-intercept form. All right, example 2, graphing in slope-intercept form. All right, so they gave it to us in what form? What form is this right here?
Standard.
Yeah, this is standard form. I want to get it in slope-intercept form. The way I do that is I move my x over, all right? So I'm going to move it over. I have to move it over by subtracting it, right? So I have negative 4y is less than negative 3x minus 8, all right? I'm not quite done. I need to do one more step. I have to get y by itself, so I need to divide everything by negative 4. Every single piece, by the way, by negative 4. So now I have y by itself, but I divided by a negative, so this guy has to flip. My slope is positive 3 over 4 because it was negative divided by a negative. And my y-intercept, negative 8 divided by negative 4 is positive 2. All right, this is slope-intercept form. All right. To graph and slope-intercept, you start right here at your y-intercept. So what is my y-intercept? 2. Yep, 0, 2, right there. My slope is 3 over 4. It is a positive slope, which means I am going to go up 3 and right 4 from this point. So I'm going to start here, and I'm going to go up 1, 2, 3. And I'm going to go right 1, 2, 3, 4. All right. And so I am going to go over here to the point 4, 5. All right. I have my 2 points, so I know where my boundary line is. Before I draw my boundary line, I need to figure out if it includes it. So I'm going to look right here. Does it include my line? It's just a greater than sign. It is not greater than or equal to. Since it's not greater than or equal to, I am going to put a dashed line. So I am still going to connect these dots, but I am going to connect them using a dashed line right here. That indicates, just like an open circle, that it doesn't actually include my line. All right? Now, when you have it in slope-intercept form, all you have to do is look at this sign to decide where to shade. If it is greater than, shade above the line. If it is less than, shade below it. By above, the best thing to do is look at your y-intercept, okay? Shade the part where your y goes up, because sometimes the lines are really steep and you can't figure out, like sometimes people confuse, oh, do the right to the line, left of the line. No, look and find your y-intercept and shade the part where that's going up if it's greater than. And so for this one, I'm actually going to shade everything up here. So when it is in slope-intercept, you can do exactly what this tells you to do, because your y is already by itself. You've already accounted for any coefficient in front of your y. So just like with lines, you can have inequalities in absolute values. So you'll notice that we have two movements on this one. We are moving left or right? Left or right here?
Right.
Yes, so it's inside. We're going to go right 2, and then we're also going to go up 1. All right, so our vertex is going to be not at 0, 0. We're going to move over right 2 and up 1. So here's our vertex, all right? And we know that we're going to be moving, you know, up 1 over 1 from each one of these. However, we also have to decide, is this solid or dashed? So what is it? Solid or dashed?
Dashed.
Dashed. So we are going to start at that 2, 1, and we are going to use a dashed line here. We're going to go this way, and we are going to go this way. All right, so instead of doing a solid line here, we're going to do a dashed line. And then above or below. So really the best place to look is at the vertex. All right, is this going to be shaded above or below? Y is what? Greater than or less than? Greater than or less than? Greater than, right? So when I shade my absolute value, I look at really the vertex. Where's my Y value going up above that vertex Y value? Is right here. So that is my shaded area for my absolute value. So first, our vertex is going to go right and down, right? And then we are going to shade below it. So you went right and down, right? Here's your vertex. It was dashed because of this. And then you look here and say, where am I going to shade it? I'm going to shade everything that's below this. So it actually, as that goes up, so does your shading. So you just stay below that V.